All right. Hello, how's it going? Welcome to the Keen Workspaces. I've always wanted to dig into cryptography, but I've always thought that it was something that is kind of reserved only for those super smart mathematicians. And I'm a software engineer. I wasn't formally trained in mathematics beyond discrete math, but as many software engineers, many programmers, many people who work with software, we have to deal with, we hear encryption and cryptography all the time. And again, each one of us is kind of scared to approach it because it really seems, very complicated, and it is very, very tough, niche. I found though this book called Serious Cryptography, Practical Introduction to Modern Encryption, where the author really says that he's making a great effort to teach cryptography in a way that it's easy to comprehend even for somebody that doesn't have crazy math training and knowledge. So yeah, that's it. So I just wanted to start a series of videos where I'm learning about cryptography and I'm sharing with you my my path and my learning experience with this book in particular. And so obviously I'll supplement materials from online. You don't need a book to learn cryptography because everything is online, everything is free. But I just like to have a I like paper, I like this, I like books, and I like that the approach that this person is taking, so we're gonna give it a try. Alright, so let's go now to the conference room and let's start with the basics of cryptography. So what is cryptography? Cryptography is the art, we call it the art of obfuscating data. Oh, by the way, our Instagram profile, check this out. Cryptography is the art of hiding data, obfuscated. Let me check the camera if it's working. Perfect. It's the art of obfuscating and making some data, some information unreadable for somebody that doesn't know what is called a key, right? So let's be a little bit more specific. I have to figure out what marker works well. So we have some data, which is hello Bob. I want to send this piece of data over an insecure mean, which can be the wires, the internet, the Wi-Fi. To send this data over the internet, I need to make sure that people that this is an eye, supposed to be an eye, people that eavesdrop, or this is an ear, or listen on this data while it gets to the destination. Bob. I want to make sure that nobody here is going to be able to know that I'm saying hello Bob. If I say hello Bob by whatever it is, whatever mean, internet or to a piece of paper, can you give this to, I don't know. I need to make sure that nobody can read hello Bob, because this can be also a more serious situation where I am where I am the commander of an army and I need to send my plans, my tactics to some other commander, some other general in some other place and coordinate efforts. Now this becomes a life and death situation. So it's very important that this data doesn't get eavesdropped, doesn't get spied when it travels through an insecure medium. So that's where cryptography comes in. Cryptography will sit right here. Imagine this is a box. Well, a black box. You don't know what's inside. You will feed the data into here, and what comes out, you're gonna feed, obviously. Actually, let's not mention this for now. You're gonna feed your data into some cryptographic algorithm, and this data is gonna become unreadable. It comes out unreadable. So, if somebody in the internet will be able to steal the packets or intercept my communication, what they will read is gonna be just garbage, like AX, B, 3, X, 1, J, dot, slash, A, Z, 1, 1, slash, B. You know what I mean? It's gonna see garbage. And so this way nobody can read my data. Now, obviously, your question will be, it gets to the destination, how can Bob how can Bob decipher this piece of data? And that's where a thing that is called the key comes in. A key is another piece of data that goes inside here. Okay. And this key is used by the cryptographic algorithm here to obfuscate the data. Now, when the data gets to destination, Bob is gonna, Bob is gonna receive it. Bob is gonna feed the same data into the same cryptographic algorithm, right? He's gonna put the key, the same key, or another type of key. That depends on the different kinds of cryptographic algorithms, right? We're just introducing the topic now, so I'm just going to generalize very much. Bob is going to use also a key, an appropriate key, let's call it, and feed it in the same kind of algorithm, and finally is going to have data. So this is the process of encryption in very, very generic terms and very simplified, very, very simplified. Now let's give a bit of a better names now. We're gonna call the data not obfuscated plain text, right? Plain text is hello Bob, or the secret coordinates of my platoons, or my bank account password. You see what I mean? There's a lot of things that we need to keep secret in life. And so the plain text, let's do a better drawing of what encryption consists of. The plain text, letter P, is going to be fed into what's called a cipher. Cipher means cryptographic algorithm. Algorithm means a set of rules and instructions to follow. So we're going to feed the plain text into the cipher, and we're going to feed a key into the cipher. Why is the key important? The key introduces entropy. It introduces chaos into the plain text. It allows us to give us a structural, precise way to give chaos to the plain text, to encrypt this plain text, right? And what I get out will be the encrypted text, right? The cipher text. I think it's called cipher text. Cipher text, yeah. Now we're gonna have cipher text. Again, this is very generic what encryption is, what cryptography deals with. Taking plain text, feeding it into a cipher together with the key. The cipher is going to have complex mathematical operations that we'll do on this data, and as a result we get back a ciphertext that looks like, again, X F 4 Z 9 slash dot dot G 6 1 dot A, you know what I mean, etc. Imagine a long random string like this. This is incomprehensible. It doesn't mean anything, guys. Now, and this is encryption. Obviously, we're also going to have decryption. Oops, need to go vertical. Okay, and in decryption, we're going to start from the ciphertext, obviously. Feed it into the cipher. Put the key, I'm just going to write the letters. Put the key, and we're going to have back the plain text. Okay? Encryption and decryption, because as we hide the data, we need to be able to de-hide it, to reread it. If not, it will be so stupid, there will be no points. So this is really the basics. This is what really encryption is about. And so in the next videos, we should dive into the different types of algorithm. We're gonna start in the next video from the pre-computer era encryption schemes, because in ancient times, you know, they were sharing secrets too in the Roman times. We're going to start from that historical time. And so we're going to look over the course of time, we're going to learn about different kinds of encryption and the implementations and a lot of exciting things. So thank you for watching. If you enjoy this, please support me. I hate when YouTubers say that, like and stuff, but at the end of the day, that's what every content creator needs support to go on, and yeah, that's it. So next video, we're gonna start with the Caesar cipher and the Vigenère cipher, the first two encryption algorithms ever created. Thank you for watching, and see you soon. Let me just stop this. All right, bye-bye. Oh, it doesn't stop. Great. I'll stop from the camera. Bye bye.